Good morning. Good morning. We'll wait for 2 minutes. 2 minutes we'll wait. Okay, good morning. Let us continue our discussion. Yesterday we started Fourier transform. What is the definition we selected? Capital X of omega equals to integral x of t e power minus j omega t dt. By simply replacing omega 0, we said it is area under the signal concept. Spectrum at 0 is area under the signal. What is the inverse Fourier definition, sir? 1 over 2 pi integral of x omega e power j omega t d omega. By replacing t place 0, what will happen on the right side? Area under the spectrum. Then we discussed some of the standard signal spectrums like decaying exponential, transform pair with 1 by a plus j omega, growing exponential 1 by a minus j omega, impulse uses 1, impulse gives us 1. Then the two-sided exponential 2a by a square plus omega square, signum function 2 by j omega. Last one we started is rectangle. Rectangular pulse in time domain is Sav function or sinc function in frequency domain? What are the conversion relations we studied, sir? Omega to F conversion formula. Omega equals to 2 pi F. Another relation 2 pi del omega equivalent to del of F. So what are the theoretical statements we have made? For a real signal, the symmetry is conjugate symmetry. For a real signal, symmetry is conjugate symmetry. Real and even again becomes what for us? Real and even in time domain is real and even in frequency domain. Real and odd becomes imaginary odd, vice versa. In a similar way, imaginary even becomes imaginary even. So these are some of the points we discussed. Some of the points. So let us continue our discussion. I'm going to the next slide. Everyone, please think of this model, sir. Find the Fourier transform of the signal shown in figure and find y of f at f equals to 1. F value is 1 means equivalent omega number 2 pi. F value 1 means equivalent omega number 2 pi. Finite length of constant amplitude means 100% it can be related in terms of rectangle. Finite length of constant amplitude. 100% it can be related in terms of rectangles. So the given graph can be written as sum of two rectangles. One rectangle from -1 to 1, another rectangle from -2 to 2. The given graph can be written as sum of two rectangles. One rectangle from -1 to 1, another rectangle from -2 to 2. Please apply that logic, yesterday's logic, and observe what is the result. Yes, Ravi, correct. We want y of f at f equals to 1 means equivalent omega number 2 pi. So the given shape can be taken as sum of one rectangle from -1 to 1. Another rectangle from -2 to 2. If you add these two graphs, it is resultant. Recollect everyone, last night logic, symmetrical rectangle, how to write? The spectrums are area 2, SA of omega into 1, positive width is 1. Area 2, SA of omega into positive width. Lower one, area 4, SA of omega into positive width is 2. Of course, the sum of these two is what's that? Y omega. What is Sav function expansion? Sin x by x. So when you expand 2 SA omega, what will happen? 2 sin omega by omega plus 4 sin 2 omega by 2 omega. SA omega expansion is like this. SA 2 omega expansion is this one. Find out the answer at 2 pi, sir. 0 plus 0. Find out the answer at 2 pi. It becomes 0. By looking at the signal, what is the first thought we need, sir? Finite length of constant amplitude means It can be linked in terms of rectangular pulses. It is directly looking like sum of two rectangles. It is directly looking like sum of two rectangles. Let us go to the next one. Please have a thought on this. Magnitude spectrum of two functions xt, yt are given. It is assumed that their phase angles are 0. Then what is the relation between yt and xt? Y omega is of course looking like compressed form of x omega. Y omega is looking like compressed form of x omega. Compression in frequency domain means what will happen in time domain, sir? Expansion. Compression in frequency means it is expansion in time domain. We know expansion means scaling factor must be less than 1. Expansion means scaling factor must be less than 1. So choice is between which options? A and D. Apply the scaling property of Fourier transform. 1 by mod alpha x of omega by alpha. It is very easy to remember. Time domain multiplied by alpha means frequency domain divided by alpha with amplitude scaling of 1 by mod alpha. With amplitude scaling of 1 by mod alpha. Because it is compression in frequency, it becomes expansion in time, sir. So choice is between A and D. Decide the correct one. Choice is between A and D. Decide the correct one. Y of omega is compression of x of omega. Extra amplitude scaling 3 is there. So right side, what adjustment we need, sir? Like scaling property 1 by mod alpha, x of omega by alpha means this is x of omega by 1 by 2. We want 1 by mod alpha also, which is not there. 1 by mod alpha also we want. So alpha is 1 by 2 according to property notation. So what is the inverse Fourier answer, sir? 3 by 2 x of t by 2. 1 by mod alpha x of omega by alpha. Very good. Most of you have given correct answer. But the first thought you read in the question is what? Compression in frequency corresponds to expansion in time. Compression in frequency domain corresponds to expansion in time. With that simple logic, you can answer it. Surya, last night also you asked me, everyone feels comfortable. I think you have to make adjustment from your side here. I'm using regular screen only. Okay. Let us discuss the next model. Everyone have a thought of this question, sir? X of t is rect 2t. What is the Fourier transform of x of 3t convolved x of t by 3? That is nothing but application of scaling and convolution. Apply scaling and convolution. Rectangle standard form is what, sir? A rect t by t style. Rectangle standard form is A rect t by t. So if you know x omega, that means you got the answer. Convolution becomes multiplication in frequency domain. Other thing is scaling property. It is given as rect 2t, but our style is A rect t by t. If you calculate x omega, that means we got the answer, sir. If you calculate x of omega. So rect 2t can be adjusted as rect t by 1 by 2. It means that rectangle covers from minus 1 by 4 to 1 by 4. So what is the Fourier transform answer we can write, sir, directly? Area half SA of omega by 4. Area half SA of omega by 4 positive width. X of alpha t means 1 by alpha x of omega by alpha. For x of 3t, 1 by alpha x of omega by alpha. Second one, 1 by mod alpha x of omega by alpha. You already know x omega, substitute there, sir. Convolution converted to multiplication and scaling property. Okay. First, you should get the idea. Our standard style is A rect t by t, but here it is given as rect 2t. Do the required adjustment, get the spectrum, sir. After that, it is bacha scaling and convolution. Very simple. The next property which we are learning is called as duality. The next property which we are learning is called as duality or similarity theorem. What is this property is, if xt transform pair with x omega, then capital X of t transform pair with 2 pi into small x of minus omega. What we are doing in duality is convert the frequency domain expression to time domain by replacing omega as a t, time to frequency by replacing t as minus omega. Normally in network subject, what we'll do, sir? Dual theorem means voltage source becomes current source, resistance, conductance. In a similar way, what are the two domains now we have? Time and frequency domain. To convert frequency domain to time domain, omega replaced as t. Time to frequency, t replaced as minus omega. How we got this property? Let me explain. What is the inverse Fourier definition, sir? 1 over 2 pi integral x omega e power j omega t d omega. If I replace t as minus t in this expression, what will happen? 2 pi into small x of minus t. I'm taking 2 pi left side. Integral x omega e power minus j omega t d omega. Wherever t is there, just write minus t. Next time interchange t and omega. T plus omega, you write omega plus t, you write, sir. So 2 pi into small x of minus omega equals to integral capital X of t, exponential, both replacements are done. Whatever the new formula we got, it is looking like forward transform definition. In the place of small xt, we got capital X of t. In the place of capital X omega, we got 2 pi into x minus omega. So by definition, they form Fourier transform pair by definition. For every transform pair, we can create the dual pair. For every transform pair, we can create the dual pair. One practical example you can say for duality, if you are having negative, from that photograph is generated, sir, from a negative. Even the photograph also, from the photograph also, we are in a position to generate negative. It is both the ways. From the negative, we can generate photograph. Reverse way also it is possible. That is what our story, time domain to frequency domain to time domain. For every transform pair, you can create the dual pair. For every transform pair, you can create the dual pair. Whatever the pairs we studied till now, on that I will ask you application of. On that I'll ask you application of duality, sir. Whatever the pairs we created till now. If you want, take a snapshot of first slide, everyone. Based on these formulas only, I'll ask some questions. Please take a snapshot, sir. First slide, everyone. I hope you have done. So based on that only, let us discuss few questions based on that only. Suppose 1 by 3 minus jt is given. Listen first, how I am solving. Listen, sir. By looking at 1 by a minus jt, you should get the idea. What is its original frequency domain form? What is the original frequency domain form of that, sir? 1 by a minus j omega. 1 by a minus j omega. We know it is Fourier transform of which functions are? Growing exponential e power at u minus t. It is Fourier transform of growing exponential. As omega is replaced as t, according to duality, t must be replaced as what, sir? As omega is replaced as t, t must be replaced as what? Small x of minus omega, directly t place minus omega we are substituting. By looking at 1 by a minus jt, you should get the idea what is its original form. 1 by a minus j omega is original form, sir. It is Fourier transform of growing exponential. Spectrum to time domain means omega replaced as t. Time to frequency means t replaced as what? Minus omega. When you are noting down this, follow this sequence. This is first available, from which we got the idea what is its original spectrum domain form. From there we have gone to time domain function. Finally this. That is a sequence you have to note down, sir. From here we have gone to spectrum. Spectrum to time domain, finally duality. By looking at 1 by a minus jt only, you should get the idea. Our original form 1 by a minus j omega. It is Fourier transform of which function? E power at u minus t. Everyone think of this. If I give 2 by t square plus 1, sir, now what will happen? It is looking like Fourier transform of which function? Originally. Because t is there. In spectrum domain, instead of t, what we should have? Instead of t, what we should have, sir? Spectrum domain 2 by omega square plus 1. It is Fourier transform of which function, sir? Two-sided. It is Fourier transform of two-sided exponential. Omega replaced as t according to duality. T is replaced as what, sir? According to duality, t is replaced as minus omega. Mod minus omega is mod omega. By looking at that expression only, you should get the idea what is its original form. Of course, you will get that idea only when you are thorough with standard formulas, sir. You must be thorough with original combinations. Similarly, you try for signum, sir. Applied duality for signum formula. We know signum Fourier transform 2 by j omega. Signum Fourier transform 2 by j omega. Applied duality for it. If you apply duality here, omega replaced as t. This side t is replaced as minus omega. As signum is odd function, SGN of minus omega becomes minus SGN omega as signum is odd function. Drag pi in the denominator, cross multiply j. Drag pi in the denominator, cross multiply j. 1 by pi t is having Fourier transform as minus j signum omega. 1 by pi t is having Fourier transform as minus j signum omega. This is what we are calling as Hilbert transform. It is an impulse response of Hilbert transform that will create 90 degrees phase angles because signum amplitude plus or minus 1. Signum amplitude plus or minus 1 into minus j means plus or minus j. So due to plus or minus j, what is the phase angle contribution, sir? Plus or minus 90 degrees. Plus or minus 90 degrees. Wherever 1 by pi t is there, it will automatically create phase angle of 90 degrees. Because signum amplitudes are plus or minus 1 into minus j means plus or minus j. Due to plus or minus j, phase angle contribution 90. Similarly, what is the Fourier transform of 1 we can write, sir? For which signal we have written Fourier transform as 1? For which signal we have written Fourier transform as 1? Impulse. When you apply duality, in the frequency domain it is constant means time domain also same constant. This side it becomes 2 pi into del of minus omega. That is 2 pi del omega. Of course, we studied in terms of f that as del f. Impulse in time is constant in frequency. Constant in time is impulse in frequency. So theoretically to say impulse in one domain becomes constant in the other domain. Impulse in one domain becomes constant in the other domain. Theoretically to say impulse in one domain becomes constant in the other domain. What is the relation between signum and step function we observed, sir? What is the relation between signum and step function? 2 into ut minus 1, from which u of t is 1 plus signum by 2. So let us find out Fourier transform of ut, sir. Constant in the time domain is impulse. Constant in the time domain. Just now we solved. 1 Fourier transform 2 pi del omega. Signum Fourier transform is 2 by j omega by 2. The Fourier transform of step function is 1 by j omega plus pi del omega. Step function is a power signal. Last night we have made a statement. Fourier transform of power signal may include impulses. Fourier transform of power signal may include impulses. Ut Fourier transform contains extra impulse. 1 by j omega plus pi del omega. 1 Fourier transform 2 pi del omega signum 2 by j omega. After simplification, this is the result. Based on this formula, everyone try this question. What is the inverse Fourier transform of u omega? What is the inverse Fourier transform of u of omega? Ut becomes u omega means application of which properties are? Duality. Ut becomes u omega means application of duality. Have a thought. Already UT formula is available. Apply duality for it. If we apply duality to this relation, what will happen? Omega replaced as t. This side 2 pi into t is replaced as minus omega. But to convert that negative frequency to positive, extra time reversal property also you should apply, sir. Because we have u minus omega. To make that as positive frequency, extra time reversal. T is replaced as minus t. Take the 2 pi on left side. U omega. U of omega. First t is replaced as minus t. Omega replaced as minus omega. First duality, then reversal property. First duality, then reversal property. Similarly, we studied rectangle in time domain is sap function or sinc function in frequency, vice versa. Opposite also true, sir. Opposite also true. How? Observe here. If I take a rectangle from minus a to a, I take a rectangle from minus a to a with amplitude 1, mathematically it is rect t by 2a. So what is the Fourier transform answer we are writing? Area 2a SA of omega into positive width a. Area 2a SA of omega into positive width, sir. When you apply duality, omega replaced as t. Omega replaced as t. This side 2 pi into t is replaced as minus omega. T replaced as minus omega. Expand that SAP functions are sin x by x. As a rectangle is even symmetric, rect minus omega becomes rect omega only because it is even symmetric. Drag pi on the left side, sin at by pi t is rect omega by 2a. It means sin at by pi t. What is the graph of rect omega by 2a? That rectangle covers from minus a to a with amplitude 1. Till now, we studied this rectangular spectrum as which filter? In Fourier series chapter, ideal low pass filter. Ideal low pass filter. Correct or not? So rectangle in time domain is SAP function in frequency, vice versa. SAP function in time domain is rectangle in frequency. Whenever this expression comes sin at by pi t, I will call that as SAP function or sinc function. Don't take serious about it, sir. If a is pi, pi by 2, 3 pi like that, it can be written as sinc pulse. With some adjustment, of course, it is SAP function. With some adjustment, it becomes SAP function. And one more funny point, if a value is pi, it becomes sin pi t by pi t. That is the sinc t. What is the Fourier transform of sinc t, sir? Rectangle from minus pi to pi. What is area under sinc function? If that is a question. What is area under the signal? Area under signal means where you are checking its spectrum, sir. Area under the sinc pulse I want means where we have to check its spectrum. At origin, its amplitude is 1. Integral sinc t dt is 1. How that integral is correct means what is signal's logic? Area under one domain, checking other domain at origin. Area under one domain, checking other domain at origin. So just go through the steps. Theoretically, to say rectangle in one domain becomes SAP function or sinc function in other domains, sir. Theoretically. How to get area under sinc function means take its spectrum and check the value at origin. Take its spectrum and check the value at origin. That is 1. But in examination, don't expect always this style only. Sin A t by pi t form, they will never give that. Don't expect that style. They may give, find the Fourier transform of these functions. So either it is SAF function or sinc function in time domain. They must be converted to which styles are sin A t by pi t, then only we can draw the spectrum. They must be converted to sin A t by pi t, then only we can draw the spectrum. So try on your own, every fellow. Do the required adjustments and try to draw the spectrum of both the functions there. Both must be converted like sin A t by pi t. Both must be converted like sin A t by pi t. First one is sin 2t by 5 by 2t by 5. But what extra we need, sir? Sin A t by pi t is our requirement. So adjust pi. Adjust. So 5 pi by 2 sin 2t by 5 by pi t. So what is the Fourier transform I can take, sir, now? That rectangle covers from minus 2 by 5 to 2 by 5 with how much amplitude? Don't forget it. 5 pi by 2 is the amplitude. 5 pi by 2 is the amplitude. Similarly, try the lower one. Try the lower one. Sinc pulse expansion is sin pi x by pi x. Come on, come on. I want amplitude of rectangle. If you tell the amplitude correctly, it means you got correct answer. In frequency domain, tell me amplitude, sir. For sinc pulse, what is the amplitude you got? Sin 4 pi t by 3 by 4 pi t by 3. It means it is 3 by 4 times sin 4 pi t by 3 by pi t. So if you draw the spectrum now, that rectangle covers from minus 4 pi by 3 to 4 pi by 3, amplitude of 3 by 4. Very good. Most of you have given correct answer. Very good. Don't skip that extra amplitude, sir. And later on scold me in the exam. Sin A t by pi t form. Sin A t by pi t form is the requirement. Anything is extra means it is amplitude of rectangle. Don't forget it. Anything extra multiplied means it is amplitude of rectangle. Like that, for every transform pair, we can create the dual pair by making what changes? Omega replaced as t, t must be replaced as minus omega. Omega replaced as t, sir. T must be replaced as minus omega. For every transform pair, you can write the dual pair. Okay. Let us discuss the next point. What is time shifting property in Fourier transform? X of t minus t naught. Actually, in Fourier series, we have written that as e power minus j n omega naught t naught into Cn. What is the difference in Fourier series and transform, sir? There n omega naught now replaced as omega e power minus j omega t naught times x omega. Their discrete frequency now becomes continuous. Because of time shifting property, we are getting extra linear phase of minus omega t naught. In e power j theta, what is the theta value, sir? Minus omega t naught. For the original phase spectrum, if you have additional component that is added is minus omega t naught. Minus omega t naught is extra added, sir. Time reversal property has changed phase spectrum. Time shifting property is also changing phase spectrum only. Everyone try this question. What is the Fourier transform of this function? E power at u minus t is the known signal for us, sir. E power at u of minus t is the known signal that is shifted. So I want Fourier transform of that. Tell me what does the numerator contains. Denominator I don't want. 1 by a minus j omega. Denominator is 1 by a minus j omega. I want only numerator of y omega. What is the numerator of y omega? Sitting in a chair for long hours is a torture, yeah. I don't know how you people are managing. In normal offline classes, we have a movement of our legs. But here, blindly sitting like that. Actually, most of the fellows will do one mistake here. What is that is, if xt is e power at u minus t, the shifted form is e power a into t minus t naught u of minus of t minus t naught. So it is like u of minus of t minus 5 in the exponential power, make the adjustment t minus 5 plus 5. Now it is in the correct form, having shift of 5 units. When you want the shift, when you want to shift the signal, complete signal must be shifted, sir. So what is the Fourier transform answer? E power 3 into 5, 3 5s are 15. 3 5s are 15, that is extra. because of shifting e power minus j omega t naught times Fourier transform of original. Most of the fellows will miss that e power 15. We cannot apply directly time shifting property there. We need an adjustment. E power a into t minus t naught, which is not there. So first you do adjustment, then you can apply. Okay. Everyone think of this model. What is the Fourier transform of sinc 3t plus 1? Sinc 3t is the known signal. And how many units of shift you have to tell me? Sinc 3t is the reference signal. You should tell me how many units of shift. I want T naught. If we assume sinc 3t as reference, what is T naught number? What is T naught value, sir? If you take sinc 3t as reference, assume the known signal as sinc 3t, what is T naught number? Minus 1 by 3. It is like sinc of 3 into t plus 1 by 3. That can be written as x of t plus 1 by 3. Assume xt as sinc 3t. That is sine 3 pi t by 3 pi t. If I substitute here t as t plus 1 by 3, we are recovering back original signal. So the spectrum covers from minus 3 pi to 3 pi with amplitude of 1 by 3. Here t naught how much, sir? Minus 1 by 3. E power minus j omega t naught into x of omega. So what is x of omega? 1 by 3 rect omega by 6 pi. T naught value minus 1 by 3. Sinc 3t is the known signal, left shifted by minus 1 by 3. If you take minus 1, gone. Thank you, Dinakar. I'm trying that. But the thing is, in online batches, if I teach 5 to 6, so almost 300 hours, I'm sitting on the chair now. So certain times I'll get irritation. Okay. Anyway, this style of teaching, we have to habituate. We have to change according to the changes that are happening. We can't do anything. Trivikram Rao, by writing that, what you will do? Only with shifting the properties over, na. What is the need of that over action? 3 into t plus 1 minus 2, if you write, how will expand that? Internally. Sinc x, sin pi x by pi x is standard. After that, it is neatly indicating t naught of minus 1 by 3. Everyone think of this model. I want Fourier transform of rect of t plus 5 divided by 4. A rect t by t is our standard form, sir. A rect t by t is our standard form. So what is t naught value? A rect t by t is our standard form. Tell me what is t naught. If I assume rect t by 4 as reference, if you are taking rect t by 4 as reference, what is t naught number? Come on, come on. Minus 5 is t naught. Only 2-3 fellows are responding. Other fellows are in drowsy mode. Sunday special. Don't be lazy, be crazy. xt is rect t by 4. Simply t is replaced as t plus 5 means we are recovering original signals. Of course, rect t by 4 means it covers from minus 2 to 2. Directly, what is the result, sir? Area 4 SA of omega into positive width. Area 4 SA of omega into positive width. This is indicating T naught as minus 5. E power minus j omega T naught into x of omega. So e power j 5 omega 4 SA of 2 omega. Assume rect t by 4 as reference. That rectangle extends from minus 2 to 2. Take its Fourier transform. T naught is minus 5. Because of shifting extra multiplier, e power minus j omega T naught. One very old gate question I'll give. Think of and answer me. Okay. Given the Fourier transform of a signal is like this. Find H0. That is the question. 4 sine 2 omega cos omega by omega. We want small H0. I am giving 3 minutes time. Decide the result. Every one of you know signal at origin means area under the spectrum is our logic. Signal at origin means area under the spectrum. Have a thought? Performing that integration is not easy. You follow another logic. Sin x by x is which function? Sin x by x is sap function. Nagarjun Rao, not correct. Sin x by x is sap function. That way you think. Ravi, you have missed something. Divided by 2 pi, I think. We can do that integration, sir. But it is not easy. Simplified way, we have to say the answer. Sin x by x is treated as sap function. Sap function in frequency domain means time domain rectangle. Think. Sap function in frequency domain means time domain it is rectangular pulse. So what I am doing is numerator sin 2 theta is there. I am expanding it. 2 sin theta cos theta. Sin 2 theta expansion is 2 sin theta. I will assume this bracket term as reference. We know it is Fourier transform of a symmetrical rectangle. Two SA of omega, which is 2 sin omega by omega. So it is 4x omega into cos square theta is 1 plus cos 2 theta by 2. 2x omega one term. Cos 2 theta expansion is e power j theta plus e power minus j theta by 2. Right inverse Fourier. 2 times xt x of t plus 2 plus x of t minus. So xt means that rectangle already there, minus 1 to 1 it covers with amplitude of 2 sir. X of t plus 2 means left shift. X of t minus 2 means right shift. This is h of t. We want h of t at origin simply 2. Only first signal has amplitude at origin. Sin 2 theta expansion is 2 sin theta cos theta. Numerator is 2 sin omega by omega. Other term cos square. Cos square can be expanded as what, sir? 1 plus cos 2 theta by 2. That is simplified like this. After that, simplification. Otherwise, numerator is 2 sin A cos B. Numerator is 2 sin A cos B. Sin A plus B plus sin A minus B. Sin A plus B plus sin A minus B. Any logic you can apply. Integration also we can perform. But SA function, SA spectrum is habituated thing. Let us go by that method. Correct, Dinakar? That is the reason middle. When I'm giving chance to note down, I'm moving here and there in the room. Thank you for your suggestion here. Thank you. Over 20 years, we are habituated to teach on the dais. Suddenly from 2 years, this overaction is happening. Sitting on the chair for long hours. I left basically the software in the job because of this only. I don't want to sit for long hours, but emotion. God will decide according to his convenience. We have to enjoy all situations. What, Mohammed? Is it a word for me? Okay. It's a beautiful question. Different ways we can solve, sir. Area under spectrum, area under simples one, that is one logic, or this way, or numerator can be adjusted as 2 sin A cos B, sin A plus B plus sin A minus B. Anyway, you follow, answer at 0 is 2. Okay. Please think of this model, sir. Some signal f of t graph is given. Some signal f of t graph is given. How to get Fourier transform of f1t and f2t is the question. Of course, for rectangle we know Fourier transform is SA function. But here, how to write f2t in terms of f1t with respect to the known property still now. How to write f1t in terms of f of t. That way you think. Till now we know reversal, scaling and shifting. So with respect to the known properties, how to write f1t in terms of f of t? What is the folded version of f of t, sir? Like this. If I take f of t minus half, that shape covers from if I take f of t minus half, that shape covers from minus 1 by 2 to 1 by 2. Similarly, f of minus t left shifted by 1 by 2. Then where it covers? Minus half to what will be sum of both the functions? Negative ramp added to positive ramp means it becomes constant, which is f1t graph or not? Directly f1t sir. So it is f of t minus half plus f of minus t plus half. Positive ramp added to negative ramp means it becomes constant with the t naught value 1 by 2 and minus 1 by 2 respectively. So what is the Fourier transform answer? E power minus j omega t naught into f omega e power minus j omega t naught into f minus omega. F of minus t is there means f minus omega. Every one of us know rectangle means SAS spectrum. But here, how to express f1t in terms of f of t with respect to the known combination? Think of how to write f2t in terms of f of t. F of t length 1 unit, but f2t length 2 units. So first we have to do expansion. F of t length 1 unit, f2t length 2 units means first we have to do expansion, sir. Later on it is right shifted by 2 units. Later on it is right shifted by 2 units. Scaled signal is shifted now. F of t by 2 is the scaled signal that is right shifted by 2 units. On the board I have written 2 expressions. Tell me which is correct one, sir. First one or second one? Everyone should respond. Scaled signal is shifted. Which is the correct expression? Look at F2t and respond. Upper one or lower one? First one or second one? Come on, come on. Oh, we have Chiranjeevi also. Very good. My favorite hero here. He is an inspiration to me in so many things. First one is correct. Because we neatly studied f of alpha t is the scaled form being shifted form is alpha into t minus t naught. F of alpha t is the scaled form means shifted form is alpha into t minus t naught with alpha 1 by 2 and t naught 2, sir. So when you apply the property here, f of alpha t means 1 by mod alpha f of omega by alpha First f of alpha t means 1 by mod alpha f of omega by alpha because of shifting e power minus j omega t naught. First scaling, then shifting. First scaling, then shifting. Okay. Let us discuss the next property, which is called as frequency shifting or modulation. If xt transform pair with x omega, if you want shift in frequency domain, time domain the signal multiplied by complex sinusoid, time domain signal multiplied by complex sinusoid, or xt e power j 2 pi fct means x of f minus fc. Every one of you are aware, modulation means converting the low pass spectrum to band pass spectrum. Without this property, there is no information transmission from one place to another place. The fundamental reason for selecting this property is what's to reduce the size of antenna, because voice signal has approximately 3 kilohertz bandwidth. 300 to 3400 hertz means 3 kilohertz bandwidth. So what is the wavelength? Antenna size is velocity of light by frequency 3 into 10 power 8 by 3 into 10 cube. Just we want 100 kilometers antenna, which is impractical to design. For that reason, we are converting the kilohertz to megahertz by shifting the spectrum, where we may have chance of reducing the antenna to 100 meters. So how it is done physically? Suppose if I take a spectrum like this, having bandwidth of 1 kilohertz, what is the meaning of x of f minus 1000? We are retaining the same information at a different place. We are retaining the same information at a different place. By doing so, what is the advantage? We are getting 1000 kilohertz is 1 megahertz, where we have chance of reducing the antenna size. So how that is done in time domain, sir? If the low pass signal xt multiplied by complex sinusoid, that will automatically cause shift of the spectrum. When we tune to radio station, the carrier frequency megahertz, but original information, voice information, which is kilohertz. Even with negligible size of antenna, we are in a position to receive the signal. If you take cell phone, what is the antenna size? Negligible. Cellular frequency microwave gigahertz. Lambda proportional to 1 by f. As frequency increases, wavelength decreases. So whenever the low pass signal must be transmitted, try to multiply by complex sinusoid, that will cause shift of the spectrum. Suppose if you want Fourier transform of cos, what is cos in terms of exponential? e power j omega naught t plus e power minus j omega naught t by 2. For the application of this property, I am adjusting extra 1. For the application of the property, I am extra adjusting 1. What is the Fourier transform of 1 we studied, sir? Constant in time. What we studied? Impulse. So based on that, what is the Fourier transform of first term? 2 pi del of omega minus omega naught, 2 pi into del of omega plus omega naught whole divided by 2. It means when you take a cosine function in time domain, what it is retaining in frequency, sir? We have 2 spikes, that is 2 impulses directly at plus or minus omega naught. We have 2 impulses directly at plus or minus omega naught. Just recollect, if the signal is real and even, what must be the spectrum nature? If the signal is real and even, spectrum must be real and even. That is satisfied in the case of cos function or not? Cos is real and even, the respective spectrum is also real and even. I'll come back to this slide. Wait, sir. I'll come back to this slide. Similarly, suppose I asked what is the Fourier transform of sine function? What is the change in the answer, sir? Middle minus divided by j. Middle minus divided by j. Pi by j del of omega minus omega naught minus del of omega plus omega naught. Middle minus divided by j. Similarly, if you want Fourier transform of a damped sinusoid, e power minus at sin omega ct ut form. Now we will assume e power minus 3t ut as reference. Write sign in terms of exponential, that is frequency shifting. Write sign in terms of exponential. Similarly, if it is asked what is the Fourier transform of an RF pulsar, radio frequency pulse. Now we will assume rectangle as reference. Write cos in terms of exponential, apply frequency shifting property. So when there is a need of applying frequency shifting properties, whenever any signal is multiplied by complex sinusoid, cos or sine function, whenever any signal multiplied by complex sinusoid, cos or sine function, take other part as reference signal and apply frequency shifting property. Okay? Please go through this. Please go through it. Any signal multiplied by complex sinusoid, cos or sine function is indication of applying frequency shifting property. On a lighter note, happy Children's Day to everyone. Enjoy, enjoy. Bacha. The thing is, I am habituated to use that word, bacha. Even my children who are studying fourth and second class, when I say something to them, they will say bacha to me. Arey bacha, even you don't know this. Okay. So when there is a need of using frequency shifting or modulation means, remember that points are any signal multiplied by complex sinusoid cos or sine function. Any signal multiplied by complex sinusoid cos or sine function is indication of applying frequency shifting property. Is indication of applying frequency shifting property. So I'm going to next slide. In the next slide, we have taken for sine function. So some graph I have shown here. By assuming rectangle rect t by 4, for which we'll obtain the spectrum, sir. Rectangle multiplied by cos means what happened to that sinc spectrum? It is right and left shifted by 10 units. It is right and left shifted by 10 units. That is a rough graph. You want it on a fresh page? Okay. I'll do it. Nothing is there. Say some graph, neatly graph is visible because as we are gone sketching it. Rect t by 4 is the signal for which this is the spectrum. If you want Fourier transform of xt cos 10t, like normal AM wave, what happened to that spectrum? Rectangle multiplied by cosine wave means it is limited to minus 2. Spectrum right and left shifted. This is what RF pulse, radio frequency pulse logic. Any signal multiplied by complex sinusoid cos or sine function is indication of applying frequency shifting property. Now everyone try to answer me this question, sir. What is the Fourier transform of sinc t cos 10 pi t? So which is the known signal for us? If you want Fourier transform of sinc t cos 10 pi t, which is the known signal for us, sir? Sinc t is the known signal. Write cos in terms of exponential. Enjoy. Assume sinc t as reference and apply frequency shifting property. Get the answer. It is xt times e power j 10 pi t plus e power minus j 10 pi t by 2. Assume xt as sinc t. What is sinc t expansion? Sin pi t by pi t. That rectangle covers from minus pi to pi. So according to property notation, first time it is plus 10 pi, next time it is minus 10 pi. Compare with properties are xt e power j omega ct form. First time plus 10 pi, next time minus 10 pi. So y of omega equals to x of omega minus 10 pi plus x of omega plus 10 pi divided by 2. So the original rectangle is right and left shifted by how many units, sir? 10 pi units. With amplitude scaling of 1 by 2. The amplitude scaling of 1 by original rectangular spectrum right and left shifted by 10 pi units. Assume sinc t as reference, write cos in terms of exponential and apply frequency shifting. We got the results, sir. In this problem only, I will make a slight modification. Think of what is the inverse Fourier transform of the spectrum shown. So the spectrum amplitude is everywhere 1 except for the range 0 to 2 pi. So we want time domain signals. What is y of t? The simple hint is from a constant of amplitude 1, if we subtract the rectangle for 0 to 2 pi range, it is giving back the shape, sir. From a constant of amplitude 1, if we subtract rectangle from 0 to 2 pi, it is giving the given shape. This is 1 from which subtract this rectangle. Already we have taken previous problems. X of omega, it is right shifted by pi units. Then only this is covered. So it is 1 minus of x of omega minus pi. So what is the inverse Fourier, sir? Constant means del t This is e power j omega ct into xt. That is del t minus x of t is sinc t. X of t is sinc t. Previous problem only hint. The given spectrum amplitude is everywhere 1 except in the range 0 to 2 pi. Please try to answer the next model, everyone. X of t Fourier transform is given as x omega. Let y of t equals to xt plus e power jt xt. So x of omega graph is also given, sir, for us, which covers from -1 to 1. Which covers from -1 to 1. The value of y omega at omega equals to 0.5 radians per second is, after applying Fourier transform with reference to x omega, get y omega value at 0.5. So think of and answer me, sir. Very easy question. Signal multiplied by exponential means frequency shifting there. Signal multiplied by exponential is frequency shifting. Carry on. What is the value at 0.5? Dwarakanath correct. Kiran Kumar correct. If you take Fourier transform here, y omega is x omega plus x of omega minus 1, sir. X of omega is the given graph. If you make right shift of 1 unit, it will be like this. But we want the answer at 0.5. For 1 unit length, height is 1 means at 0.5 it becomes 0.5 here. So y of omega at 0.5 is, original x omega at 0.5 is 1, sir, but the shifted version has 0.5. For 1 unit it is 1 means at 0.5 it is 0.5 only. Very easy question. Everyone think of this. What is the inverse Fourier transform of this term? Spectrum is given as x of 4 omega plus 3. Find the answer in time domain. It is indicating application of two properties, sir. Omega becomes 4 omega means scaling. Later on frequency shifting also. Array, after doing addition, you don't know what is the graph. Ramp plus constant means that ramp will raise. What is the need to draw the graph? We want that to check the value at 0.5 minus 1 to 0 as it is. 0 to 1 ramp plus constant means it will further raise. Ramp plus constant, first class only we discussed. It is not a new thing for you. Ramp amplitude raised by that many units. Let me see how many of you will give me prompt answer for this. Application of two properties are scaling and frequency shifting. I want answer in terms of xt. My habituated style is first scaling, then shifting. I will do habituated style for me. Of course, with omega c minus 3 by 4. First concentrate on x of 4 omega sir. Scaling. Enjoy karo. Correct, Bhanu Prakash. Very good. According to property style, x of 4 omega must be adjusted like what, sir? Omega by alpha 1 by mod alpha means 1 by 4 is not there. X of 4 omega is like omega by alpha 1 by mod alpha. So what is the inverse Fourier of that? 1 by 4 x of t by into e power j omega ct. First for x of 4 omega, this quantity becomes 1 by 4 x of alpha t into e power j omega ct. So now you think of what is the Fourier transform of x of 2t plus 3 into e power minus j phi t. It has three properties: time scaling, time shifting, and frequent shifting. Xt becomes x of 2t means time scaling. Shifting is there. Even extra multiplied by exponential means frequency shifting is also there. Think of don't type that expression, it will be very big. You try. For understanding purpose, I am writing this as some z of t into e power minus phi t. So what is z of t? I am taking, sir, x of 2t plus 3 I am assuming as zt. It is like x of 2 into t plus 3 by 2. According to property notation, alpha 2 t naught minus 3 by 2. Alpha 2 t naught minus 3 by 2. So what is the Fourier transform? 1 by alpha x of omega by alpha. X of 2t means 1 by alpha x of into e power minus j omega t naught into e power minus j omega t naught. Keep it aside. So what is y of omega now? Z of t into e power j omega t means omega minus omega c. So in the assumed expression, directly omega replaced as omega plus 5 z. This is the complete answer. Time scaling, time shifting I have done separately. Finally, the frequency shifting modulation property. We should follow the sequence correctly. Otherwise, you will get wrong answers, sir. Whoever got correct answer, excellent. If you got wrong answer, try one more time for improving yourselves. In today's class ending, I may give combination of 8 to 10 properties as one problem for more practice. Previous problem, 2 properties we applied. This problem 3. So slightly I will improve the number of properties. Okay. Go for breakfast for 40 minutes. Again, we'll continue. 40 minutes. Complete your breakfast and come back, sir. Okay, I hope you are back, everyone. Please go through this model, sir. Fourier transform of x of t is 2 rect of 0.25f. We want Fourier transform of xt cos 2 pi t. Signal multiplied by cos sin or exponential means we know it is modulation. Now it is given as f symbol, sir. What is the meaning of 2 rect of 0.25f? Internal it is f by 4. Internal it is f by 4. So that rectangle covers from -2 to 2 with amplitude of 2. So with respect to f symbol, apply the property and decide what is the correct result. xt e power j 2 pi fct means x of f minus fc. So try to use that and check what is the correct answer, sir, out of the given options. xt cos 2 pi t. Cos 2 pi t is expanded like e power j 2 pi t plus e power minus j 2 pi t by 2. Decide which is the possible answer, sir. Dinakar, check the result. First time FC value +1, next time FC value -1. So when you take Fourier transform, x of f minus fc, here x of f plus 1 divided by half into x of f minus 1 means rectangle right shifted by 1 unit such that it covers from -1 to 3, sir. Original amplitude 2, 2 into 1 by 2 becomes 1. Half into x of f plus 1 means same rectangle left shifted by 1 unit. So it covers from -3 to 1. When you add both rectangles, that will look like which option? When you add both the rectangles, it will look like second option. From where triangle came, Kiran Kumar? Huh? Rectangle is shifted. Are we doing any convolution here? Only rectangular spectrum is right and left shifted by 1 unit, sir. Only rectangular spectrum right and left shifted by 1 unit. Okay. Think of this. A signal xt with bandwidth b is put on a carrier cos omega ct with omega c very much greater than b. Of course, you are aware carrier frequency means megahertz, signal frequency generally kilohertz. The modulated signal xt cos omega ct is then applied to the system shown in figure. The block diagram representation is given, sir. So what are the two signals we multiplied? xt cos omega ct multiplied by cos omega ct plus theta. Later on, they are passed through filter. Later on, they are passed through filter. Get the output. Of course, if you adjust 1 by 2, what is 2 cos A, cos B there? Cos A plus B plus cos A minus B. As omega C is very much greater than B, 2 omega C is further greater. So it cannot be passed, sir. It cannot be passed. So output contains only what? xt cos theta 1 by 2 times 2. It is actually coherent detection. Demodulation of DSBSC or not? Demodulation of DSBSC. Coherent detection. Modulation means band pass filter. Demodulation means we are going for low pass system. Any signal multiplied by complex sinusoid cos or sine function is indication of applying frequency shifting property. Okay, let us discuss the next property, sir. The next property which we are discussing is called as a time differentiation. If xt transform pair with x omega, then d by dt xt transform pair with, how we have written in Fourier series, sir? Jn omega naught times Cn. Jn omega naught times Cn. But what is the change now? N omega naught replaced as omega. N omega naught replaced as omega. What is the disadvantage we checked for this property, sir? What is the disadvantage of this property? It is missing the DC component. It is missing the DC component. If you replace omega 0, result becomes 0. It means Fourier transform of d by dt xt whole divided by j omega will not guarantee our original spectrum, sir. Fourier transform of d by dt xt whole divided by j omega will not guarantee our original spectrum. Why? Observe here. If I take step function, what is differentiation of step function? Impulse. If I apply Fourier transform here, j omega x omega equals to 1, from which x omega is 1 by j omega, which is the wrong answer. Because under duality we checked ut Fourier transform is 1 by j omega plus pi del omega. Where pi del omega is gone, sir? Mathematically u0 1 by 2. Mathematically u0 1 by 2. When 1 Fourier transform is 2 pi del omega, 1 by 2 has to produce pi into del omega. When one Fourier transform 2 pi del omega, that jump location 1 by 2 has to produce how much? Pi del omega, but it is lost by property because in the property the extra multiplier is j omega. J omega into del omega result is 0. J omega into del omega result is 0 according to product property of impulse. So if we apply time differentiation, del omega term is lost. Del omega term is lost since j omega into del omega equals to what? 0. Whenever spectrum has impulse at origin, don't apply this property. Whenever spectrum contains impulse at origin, don't use this property because it is missing that component, sir. J omega into del omega equals to 0. You also note down with another color pen. Step function Fourier transform. By using time differentiation, we got 1 by j omega, which is wrong answer. I have shown you here with another color pen what component is missed. 1 by 2 has to generate pi del omega. That is missed by differentiation property, sir. That is missed by differentiation property. So if we apply time differentiation, there is a chance del omega term may be lost. If you apply time differentiation, there is a chance del omega term may be lost. Whenever spectrum has impulse at origin, don't apply this property because it is losing that component, sir. It is losing that component. I will give a model for you. Try to answer it. A signal yt Fourier transform is given as y omega. dyt by dt Fourier transform is given as 1 minus e power minus j omega by 2. Find y of t is the question. Get the signal. Everyone think and respond. Y of t Fourier transform is given. dyt by dt Fourier transform 1 minus of e power minus j omega by 2. Get the signal y of t. Think of that. If you take Fourier transform here, j omega y omega equals to 1 minus e power minus j omega by 2, from which y omega answer is 1 by j omega. Other term, according to the formulas we studied, Which denominator has that 1 by j omega term, sir? According to the formulas we learned, signum. Signum Fourier transform is 2 by j omega. So what is the inverse Fourier? 1 by 2 signum. Extra exponential here represents shift of 1 by 2 units. Extra 1 by 2 represents here shift of 1 by 2 units. Denominator 1 by j omega corresponds to link to signum. Because we know signum Fourier transform is 2 by j omega. Very good, Nitish. Very good. Think of the right side question, sir. Some spectrum is given, we want a differentiated signal at origin. We know if you want one term at origin, it becomes area under other domain. So it is linked to inverse Fourier definition, sir. X of t is 1 over 2 pi integral x omega e power j omega t d omega. That is inverse Fourier. If you differentiate with respect to t, right side it is differentiation of exponential. If you differentiate with respect to t, sir, right side it is differentiation of exponential. So what is extra multiplier? J omega. So you want d by dt xt at origin means simply integrating the spectrum. 1 over 2 pi integral j omega x omega. In this problem, what is the range given, sir? Minus 1 to 1. Substitute the data and simplify. Substitute the data and simplify, sir. X of omega range in the question is minus 1 to 1 range. Just perform integration. One by 2 pi minus 1 to 0 range. Amplitude is given as minus j root pi. 0 to 1 range plus j root pi. Of course, integral omega becomes omega square by 2. Do mathematical simplification. Substitute the limits. Integral omega becomes omega square by 2. After simplification, that will be the result, sir. Differentiated signal at origin means area under respect to spectrum. Differentiated signal at origin means area under respect to spectrum. Okay. The next property which we are discussing here is named as frequency differentiation. Frequency differentiation. We cannot compare this property with last chapter, sir. The reason is, in the last chapter, spectrum is discrete. Fourier series spectrum discrete. But here spectrum continuous. D by d omega x omega is transform pair with minus jt xt. If you want differentiation frequency, what will happen in time domain? Multiplied by minus jt. Last property d by dt replaced as j omega. This property d by d omega replaced as minus jt. So what is the observation we can make here, sir, from the two properties? D by dt replaced as j omega, d by d omega replaced as minus jt means, what is the observation we can make from the two properties? Differentiation with respect to one variable corresponds to multiplication by other variable. When you differentiate with time, it is multiplied by j omega, sir. But if you differentiate with respect to frequency, it is multiplied by minus jt. Differentiation with respect to one variable corresponds to differentiation with respect to one variable corresponds to multiplication by other variable. See, sir, everyone see the screen. Laplace what will do? J omega place will substitute s, sir. J omega place s, sir. If you drag j in the denominator, then it becomes d by ds is minus t. If you drag j in the denominator, d by ds becomes minus t. Differentiation with respect to one variable corresponds to multiplication by other variable. Multiplication by other variable. Suppose if you are expecting what is the Fourier transform of t times e power minus at ut, what is the known signal, sir, for us? Decaying exponential. Decaying exponential. So what is the Fourier transform answer? For t, the multiplier is j into d by d omega. See the property. If I take t, both sides multiply the property by extra j, sir. Both sides multiply by extra j. J into d by d omega of original spectrum. So that can be simplified as 1 by a plus j omega whole square. Multiplied by t means other domain it is differentiation. This is a graph of t times e power minus at ut, sir, roughly. Multiplied by t means other domain differentiation. Okay. Suppose it is asked, try to get Fourier transform of this function, sir. What is the Fourier transform of y of t? Which is like a ramp signal defined for a specific interval -1 to 1. Think of everyone. How to get Fourier transform of this one? There are two ways we can answer this question, sir. One way, I can take a ramp which is there for all time, just t, sir, multiplied by rectangle for the interval -1 to 1. If I multiply this ramp signal and constant, of course, we are retaining ramp for that portion -1 to 1. Ramp signal multiplied by constant means that one. So you can say yt is t into rect t by 2. So what is the Fourier transform? J into d by d omega. Every one of you know what is the Fourier transform of this, sir? Rectangle 2 SA omega 2 SA. It is a straight line for the interval -1 to 1. So you can multiply t with a rectangular pulse. That is one technique. Other techniques are to convert ramp to constant. We may go for differentiation. Find out the slope here. It is 1. 2 by 2 becomes 1, sir. So what is y dash t? Differentiation of positive ramp is positive step for the interval -1 to 1. Not only that, at the point of jump location, at -1 and 1, we have jump location. Extra, we are getting impulses. Be careful. Most of you may miss this component, sir. Differentiation of straight line is constant for that interval. At -1, we have a negative jump. At 1 also, we have negative jump. Extra impulses. So y dash t equals to rect t by 2 plus 2 impulses minus del of t plus 1 plus del of t minus. So what is the Fourier transform? J omega y omega equals to 2 SA omega e power minus j omega t naught e power minus j omega t naught. First time -1, next time +1. Of course, further simplification is needed, sir. Further simplification is on the left side. Even if you perform differentiation, both answers will be same. On the left side, it is like u by v. Even if you perform differentiation, both answers will look like one and same, sir. Both answers will look like one and same. But time differentiation, what is the extra care? If you differentiate ramp segment, we are getting rectangle. At the point of jump location, impulses extra. At the point of jump location, impulse are extra. Don't forget. Earlier we mentioned that there are two signals for which time domain, frequency domain solutions are same. One example we have taken is periodic impulse train, sir. If you take a periodic impulse train, again the spectrum is periodic impulse train. One more signal we consider is Gaussian. Gaussian function spectrum also Gaussian only. How Gaussian spectrum becomes Gaussian, now we are proving. Everyone see the screen. After my completion only you note down, sir. Everyone see the screen. After completion of my explanation, you can note down. Suppose I have selected x of t as 1 by root 2 pi e power minus t square by 2. Of course, a bell-shaped curve Gaussian. 1 by root 2 pi e power minus t square by 2. What is d by dt xt? What is d by dt xt, sir? 1 by root 2 pi exponential term means again exponential. T square by 2 becomes minus 2t by 2. 2 cancellation. So it can be further written as d by dt xt equals to minus t times x of t. Because 1 by root 2 pi e power minus t square by 2 is what's that? X of. Assume this as equation 1. What are the properties we know? Just now we studied d by dt replaced as j omega, d by d omega replaced as minus jt, d by dt replaced as j omega, d by d omega replaced as minus jt. If I want to take Fourier transform here, for a d by dt we have a direct replacement as j omega, sir. For d by dt j omega. D by d omega expects minus jt. So multiply extra by j both sides. Multiply by extra j. Now you take Fourier transform. What will happen? J omega x omega equals to d by d omega x omega. First I am multiplying both sides by extra j. J into d by dt xt is this. So that is further simplified as, what is the expression? Minus omega x omega. Assume equation 2. Equation 1 and 2, they resemble like same or not? Equation 1 and 2, they are looking like same or not, sir? So, as equations 1 and 2 are looking like same, x omega must be same as x of t. As equations 1 and 2 they are looking like same, x omega must be same as x of t. Therefore, x of omega must be looking like c into e power minus omega square by 2. We should find out that unknown c value now. Suno. As equations 1 and 2 are looking like same, the answer must be same, sir. What is capital X0 answer right side? Simply C. Spectrum at origin becomes right side C. Spectrum at origin corresponds to area under the signal. Spectrum at origin corresponds to area under the signal. That is 1 by root 2 pi e power minus t square by 2 dt. Area under Gaussian function already we have used, sir. E power minus ax square dx means we know the result as root pi by a. So if I solve it now, 1 by root 2 pi root pi by 1 by 2, that becomes 1. Capital X0 is 1 means C value 1. Capital X0 1 means C value 1. Therefore, 1 by root 2 pi e power minus t square by 2 is having Fourier transform as what, sir? E power minus omega square by 2. Gaussian spectrum is Gaussian itself. Everyone see here. First xt we assumed as 1 by root 2 pi e power minus t square by 2. What is d by dt xt, sir? 1 over root 2 pi as it is, exponential also as it is, minus t square by 2 differentiation becomes what? Minus 2t by 2. Assume that as equation 1. For the application of property, I multiplied by extra j. For the application of property, I multiplied by extra j. That has produced this answer. As equations 1 and 2 are looking like same, x omega expression must look like xt. So x omega is assumed as this. How to find out? See, spectrum at 0 is area under the signal, we got 1. Therefore, Gaussian spectrum is Gaussian. Gaussian spectrum is Gaussian. Please go through the steps. Only two signals have that chance, sir. Time domain, frequency domain will look like same. One is periodic impulse train, the other one Gaussian. Only two signals have that chance. Fourier transform of Gaussian function is Gaussian itself. A beautiful question was asked this year for GATE electrical students. I'll give that question, give me correct response, everyone. Very good question, sir. First you complete this, then I'll give that model for you. Okay, moving to next slide. What is that question asked is, let f of t is even function. D by d omega f omega equals to minus omega times f omega for all frequencies. And spectrum at 0 is 1. Then what is the nature of small f0? What is signal at origin? Is the question, sir. These are the options. F of t is even function. D by d omega f omega equals to minus omega f omega. Spectrum at origin is 1. Then that fellow wants small f0. Just now we solved it, is same question. See your notes and tell me what is the correct answer for f0. Come on, bachas. Acha, emotional fellow, I have to write this as 0. Small f0 is 0, sir. First option. Which is correct answer? Arey, bachas, already we derived d by d omega f omega is minus omega f omega. What we got in the last slide? Same type or not? So what is x of t form? 1 by root 2 pi e power minus t square by 2. Small x0 is 1 by root 2 pi from the last slide. This is for Gaussian. Of course, Gaussian is even. F0 is 1 by root 2 pi from last slide. Definitely answer less than 1. Definitely answer is less than 1. Hint is available in the last slide. This expression is satisfied by Gaussian function like this. Tell me. What is xt we assumed here? 1 by root 2 pi e power minus t square by 2. What is small x0 answer, sir? 1 by root 2 pi, which is definitely less than 1. Actually, in the exam hall, the fellow should get the idea that expression corresponds to Gaussian. Otherwise, no one can answer it. Okay. Maybe last slide I have proved for a specific value, sir. Last slide. In general, Gaussian Fourier transform is root pi by a e power minus omega square by 4a or root pi by a e power minus pi square f square by a. In last page, a value 1 by 2 I have chosen. Cross check if you want. In the last page, I have chosen a value 1 by 2. 100% this generalized answer is correct or not. You cross check, bachas. The last page, a value 1 by 2, it is obeyed or not? Root pi by 1 by 2 means root 2 pi. Drag it on left side, 1 by root 2 pi. That is what we selected, 1 by root 2 pi. What, bachas? Is it correct or wrong? So from this generalized formula, you only tell me, if I want area under Gaussian function, take spectrum at origin. If I want area under Gaussian function, take spectrum at origin. If I replace omega 0 or f equals to 0, what is the answer? If you replace omega 0 or f equals to 0, sir, what is the answer? Root pi by a is standard or not? Root pi by a. What happened, Pradap? Not audible? What about others, sir? It is not audible for you? Okay. Our laptops are systems, they are not human beings, na? Working like machines. Machine, it is a machine. Suppose if I substitute a place pi, sir. Use F notation formula. If I substitute a place pi, root pi by pi is 1. It is simply e power minus pi f square. If I substitute a plus pi, it is simply e power minus pi f square. Okay. Let me ask you one multiple property question again. What is the inverse Fourier transform of? Just for understanding, I am giving, sir. Competitive exams, they'll give only two properties. Just for your understanding, one question I am discussing. What is the inverse Fourier transform of this expression? If you see this type of problems, where to start is a question mark for you. Where to start? So now, 1 by a plus j omega is the known formula. 1 by a plus j omega is the known formula. First it is shifted, sir, in frequency domain. So first property, frequency shift. Later on it is shifted in time domain. So it is time shifting. Multiplied by exponential means shifted in time. J omega indicates time differentiation. Last property indicates frequency differentiation. 1 by a plus j omega is the known formula. First it is shifted frequency shifting. Later on time shifting. J omega multiplier means time differentiation. Finally frequency differentiation. Enjoy. Make a try. What sequence to be followed I have given. Carry on, carry on. First 1 by 2 plus j omega means e power minus 2t ut. Then 1 by 2 plus j into omega minus 5 having omega c number 5, sir. So e power j 5t into x of t. Later on it is multiplied by exponential. That indicates shifting, sir. E power minus j omega t naught style. So with the t naught 3, e power j 5 into t minus 3, e power minus 2 into t minus 3 u of, I don't want to repeat. Let us assume this quantity x omega, this becomes xt, sir. J into d by d omega of j omega x omega. Rest of the term, this term I assumed as x omega here. What is the inverse Fourier? Bracket term d by dt xt, j into d by d omega means t multiplier. Bracket term d by dt xt, this is t multiplier. We know x of t, substitute there. We know x of t, sir. So to solve this type of example, where to start is a big question mark. 1 by a plus j omega is the known formula. First it is shifted in frequency domain, frequency shifting. Later on exponential term is multiplied, time shifting. Like that we have to follow sequencer. Okay. The next property which we are learning is called as convolution, sir. Next property which we are learning is convolution. So let us discuss it. Convolution in time is multiplication in frequency domain. X of t convolved h of t is x omega into h omega. H of t is impulse response. H omega is frequency response. Fourier transform of impulse response is called as frequency response. The main application of this property is wherever we are using the word filter, sir. The concept of filtering is possible because of this property. Wherever we are using the word filter. Let me explain what advantage we are getting by converting convolution to multiplication. What is convolution of two equal length rectangles we studied, sir? What is convolution of two equal length rectangles we considered? Which shape? Triangle. So now we are in a position to know directly Fourier transform of this triangle. How? For each rectangle, what is the Fourier transform? Here, area 1 SA omega by 2, second one also same thing. So automatically SA square omega by 2 or not. Rectangle Fourier transform is a function. Triangle Fourier transform is SAS square omega by 2 or sinc square. Same answer can be also written as sinc square omega by 2 pi. Sinc square omega by 2 pi. One more thing. Decaying exponential convolved by decaying exponential. If you want to know what is the time domain signal, the Fourier transform of this one is 1 by a plus j omega whole square. Just now we discussed it is looking like Fourier transform of which functions are t times e power minus at ut. T times e power minus at u of t. When you convolve decaying with itself, resultant answer is 1 by a plus j omega whole square. It is nothing but Fourier transform of this function. I will come back to this slide. Wait, sir. I will come back. In a similar way, suppose I am asking decaying convolved by growing exponential, what is the time domain answer, sir? Every one of you know Fourier transform of these functions. 1 by a plus j omega into a minus j omega. That becomes omega square plus a square. Numerator we need 2a. Numerator we need 2a. This is looking like Fourier transform of which function, bachas? E power minus a mod t. So when you convolve decaying and growing exponential, it becomes two-sided or double-edged exponential. In a similar way, what is convolution of Hilbert transform with itself? Morning at duality we studied this as Hilbert transforms. So what is the Fourier transform of 1 by pi t answer? Minus j signum omega multiplied by same thing. Minus j signum omega multiplied by same thing. That is simply j square. Signum whole square is 1, sir. J square means minus 1. Constant in frequency domain. What will happen in time domain? If you take constant in frequency domain, what will happen in time domain, sir? Impulse with negative side. Impulse with negative side. If the question is sin at by pi t convolved by sin at by pi t. Now you think of and tell me what will be the time domain answer, sir? You want to convolve SA function with itself. What will be the resultant answer? Come on, bachas. Convolution of sin at by pi t with itself. What is the result? Take their Fourier transform, you will know. Venkatramana, correct. Fourier transform, first one, rectangle from minus a to a, frequency domain. Second one also, rectangle from minus a to a. When the two rectangles are multiplied, 1 into 1 becomes 1, that is another rectangular spectrum. Of course, it is Fourier transform of sin at by pi t. Rectangle multiplied by rectangle is rectangle, sir. It is actually Fourier transform of sin at by pi t. We can also show that convolution of Gaussian function with itself is Gaussian. This problem I'll solve in few minutes, sir. So I have written theoretically, convolution of Gaussian function with itself is Gaussian. So according to these pairs, what we have to understand, when convolution is converted to multiplication, whatever the right-sided quantity we have, if it has Fourier transform, only in 2 steps we are knowing the result. There is no need of folding, shifting, multiplication, integration, overaction. If the Fourier transform of the right side quantity is defined, automatically we will know the answer. So when you convert convolution to multiplication, number of mathematical steps are reduced. Okay? Please go through this page first. Decaying convolved by decaying t times e power minus at ut. Of course, this particular formula we used even in convolution chapter also directly. We use it there also, sir. I'm moving to next slide. These are some more combinations we observed. Those who have completed that combination, think of this question, sir. What is Fourier transform of y of t, which is looking like M shape? M for master. Think and answer me. How to get Fourier transform of that shape M? Simple hint is it is sum of two functions, sir. Tell me what are the two functions? To generate that graph, it is sum of two functions. What are the two functions to be added? From a rectangle, subtract the triangle. From a rectangle, try to subtract the triangle. That will create that shape. Constant minus positive ramp is negative ramp. Constant minus negative ramp is positive ramp. Rectangle minus triangle, sir. So this is rect t by 2. This is a tri t. Of course, we know Fourier transform of both. What is the Fourier transform of first one? 2 SA omega triangle. Just now we discussed in the previous slide. Triangle answer available, sir. Previous slide. Rectangle minus triangle is simple logic, sir. Okay, wait for a while. What happened, Dinakar? Some very good questions are there on this. Let us discuss that. Convolution property. Think of this. Input is cos 2t plus sin 60. System is SAF function. Find the output. Input sinusoidal means output is also sinusoidal. Sin 80 by pi t means what is the Fourier transform? Sin 80 by pi t means what is the Fourier transform, sir? It is a rectangle that covers from -4 to 4 with amplitude 1. That is the ideal low pass having cutoff frequency 4. Input frequencies are 2 and 6. So which component is passed? Cos 2t. The given system acts like an ideal low pass filter. The given system acts like a ideal low pass filter. So it is passing only cos function. Suppose we have given sin 60 as the input, only sin 60 as the input. What will be the output, sir? Suppose we have applied sin 60 as the input. What is the output? Zero. It cannot be passed. Okay, think of this. Input signal is now taken as sum of two SAF functions, sin omega 1t by pi t plus sin omega 2t by pi t. Also stated omega 1 less than omega 2. Later on, they are passed through a rectangular spectrum, means that is another SAF function. Find the output in each case. There are different expectations. What is the output in each case? These are the conditions given. In the problem statement, it is stated that omega 1 less than omega 2, omega 1 less than omega 2, in the first bit we assumed that even the cutoff less than omega 1. Even the cutoff frequency less than omega 1. What is the output in the first bit? Very good. I expected that answer from you. 0 is wrong answer. You do one thing. Take your own numbers to answer this. If I take omega 1 as 1, sir, first time the rectangle covers from -1 to 1. If I take omega 2 as 2, then the rectangle covers from -2 to 2. First time it is mentioned that omega f less than omega 1. For your understanding, suppose I have taken 0.5, sir. First rectangle as it is passed. Rectangle multiplied by rectangle means same answer. First rectangle is as it is passed till 0.5. Second rectangle is also passed till 0.5. So first time the output is 2 sine omega ft by pi t. Both rectangles are passed as it is till 0.5. For understanding purpose, I assumed omega 1, 1, omega 2, 2. Rectangle multiplied by rectangle means again rectangles are. First one is passed till 0.5, next one is also passed till 0.5. So 2 sine omega ft by pi t. What will happen for the second time? We assume now cutoff lies between omega 1 and omega 2. Between 1 and 2, suppose I have chosen a number like 1.5, sir. Between 1 and 2. First one as it is passed. First one as it is passed. Second one is passed till omega f only. Till omega f only. Last case we are saying even cutoff less than omega f. Suppose we have chosen 2.5 as omega 2 is 2, sir. Last case what will happen? Output equals to input. As it is passed. Output equals to input. Be careful with first bit. Every fellow's emotion is 0, but it is not 0. To avoid that confusion only, I selected the question immediately. Sinusoid means single frequency. This SAP function has a band limited range. It is passing certain range, band limited range. Okay. Please think of the first bit. Find the output of the system having impulse response as 8 sinc of 8 into t minus 1, for which input applied is cos pi t. Try to expand that sync pulse like sin 80 by pi t styles are. Then you can say the answer. Try to expand that sync pulse like sin 80 by pi t. Then you can decide what is the answer. Tell me the result. Very good. Sorry. Input is cos pi t. System is 8 sink of 8 into t minus 1 means 8 sin of 8 pi into t minus 1 by 8 pi into t minus 1. Extra 8 jump. Without the delay, sin 80 by pi t means what will draw? Without the delay, sin 80 by pi t means a rectangle from minus 8 pi to 8 pi. But it is causing shift of 1 unit means e power minus j omega t naught. Causing shift of 1 unit means e power minus j omega t naught. Input frequency pi, cutoff 8 pi means it can be passed, sir. But output is shifted by 1 unit. System delayed by 1 unit means output is delayed version of input. Output is delayed version of input. Try to convert that to sin 80 by pi t style. Then you will know the answer. Second bit also easy. Input is Gaussian function that is applied to a matched filter. Matched filter job is it must be folded and shifted version of original signal. Of course, nothing is mentioned about shifting. We have to match the input signal. So h of t is also e power minus pi t square. Fourier transform of output we want, sir. Input Gaussian, system Gaussian. Try to get the spectrum of output, which is the correct option. Input is Gaussian. System is also Gaussian. Find the Fourier transform of output. Output is GT convolved HT. So YF is GF into HF. E power minus pi f square into e power minus pi f square. A power m into a power n means a power m plus n. A power m into a power n is a power m plus n. E power minus 2 pi f square.
Dear students, wait for 5 minutes. Dear students, wait for 5 minutes. Dear students, wait for 5 minutes.
Sorry, my power is gone. I hope you are there. Okay, okay. So last question, it was asked about Fourier transform of output, sir. That is input spectrum multiplied by system response. So after doing that multiplication, what will be the new result, sir? E power minus 2 pi f square. E power minus 2 pi f square. Similarly, think of this, sir. A shifted Gaussian spectrum is given. Asked for nature of the signal. Whether signal is real or complex, even or odd. Shifted Gaussian spectrum is given. So tell me the answer. For that shifted Gaussian spectrum, decide what is the time domain signal nature. Yes, sir. Respond. We have to apply two properties here. One is the frequency shifting. The other one, Gaussian function standard spectrum. Yt e power j2 pi fct means y of f minus fc e power minus pi t square means e power minus pi f square. So use that hint. E power minus pi t square into e power j2 pi fct. In the problem statement, e power j theta is there means it is complex. So look for conjugation property. What is x minus t answer? E power minus pi t square into e power minus j2 pi t. Then conjugate of that e power minus pi t square into e power j2 pi. Xt equals to x star of minus t is called as which behavior? Xt equals to x star of minus t is conjugate even behavior. Conjugate even. Prajakta, once again you do relogin. It is audible to everyone. You relogin. That's what I'm saying, ma. Just relogin or go to your audio settings. Suppose I have given just e power minus pi f square. Then what should be your answer, sir? If I have given only e power minus pi f square and asked for what is nature of xt, what will be your answer? Come on, come on. Oh, full emotion, everyone. Very good. Then it becomes real and even. Because it is simply e power minus pi t square. Everyone make a try for this model. Using convolution property of Fourier transform, get the convolution of given combinations. Rect T convolved cos pi t. Rect T convolved cos pi t. Take Fourier transform and multiply the spectrum. A rect T by T Fourier transform is AT SA omega T by 2 cos omega naught T spectrum is what, sir? Pi into del of omega minus omega naught plus del of omega plus. I have given the formulas for you. Simplify and tell me. Rect T convolved cos pi t. Multiply the spectrums and find out time domain signal. Multiply the spectrum and find out the time domain signals are. Come on, I am expecting answer from you, bachas. क्या हो गया बेटा? Dwarkanath, that is second bit answer, bacha. I'm asking first bit. No. Nitish, check your answer. Acha, you have written that way. Okay. Correct only. Gauri Mahadevi, correct ma? Ravi, correct? Very good. Venkatramana, Ravi. Rect T convolved cos pi t means when you take Fourier transform SA omega by 2 into pi into del of omega minus pi plus del of any term multiplied by impulse means product property of impulse x omega into del of omega minus omega naught is x of omega naught multiplied by del of omega minus omega naught. So we are checking this SAS spectrum for which frequencies? Plus or minus pi. If I substitute omega place pi, sir, sin pi by 2 means 2 by pi. Even if I substitute minus pi also, sin minus pi by 2 by minus pi by 2 means same answer. Of course, the bracket term is Fourier transform of cos. Sin pi by 2 by pi by 2, that is due to pi frequency. Sin minus pi by 2 by minus pi by 2, both are 2 by pi only. Without solving second bit, the answer is 0. Because what is the modification in second bit? Rect t convolved cos 2 pi t means we are checking this SAS spectrum now for which frequencies are plus or minus 2 pi. We are checking SAS spectrum for plus or minus 2 pi. Sin pi 0, sin minus pi also 0. So, everyone think of the third bit. Sinc t convolved sinc t by 2. Think of the third bit. Sinc t convolved sinc t by 2. Srikanth, correct. Sinc t convolved sinc t by 2 means sin pi t by pi t convolved by sin pi t by 2 by pi t by 2. What is the Fourier transform? Both functions are. First time the rectangle covers from minus pi to pi with amplitude 1. Next time it is another rectangle covers from minus pi by 2 to pi by 2 with amplitude 2. After doing multiplication of both rectangles, that rectangle extends from minus pi by 2 to pi by 2 with amplitude of 2. What is the inverse Fourier of this rectangle, sir? Sin at by pi t form. If you drag that 2 in the denominator, answer becomes sinc t by 2. Sin pi x by pi x is sinc x. Sin pi x by pi x is sinc x. It means if you convolve two sinc functions with frequencies alpha, beta, sir. If you convolve two sinc functions with frequencies alpha, beta, resultant is also another sinc function with minimum alpha, beta or maximum. We are retaining minimum frequency or maximum? Minimum of alpha, beta. Because out of pi and pi by 2, we have retained pi by 2 frequency. If you convolve two sinc pulses with frequencies alpha, beta, resultant is another sinc pulse with minimum of alpha, beta. That is the point of observation. Minimum frequency we are retaining, sir. Minimum. Everyone think of the last bit also, D bit. Sinc t convolved e power j3 pi t sinc t is asked. Application of two properties there. Convolution and frequency shifting. Convolution as well as frequency shifting. Application of two properties there. Carry on, carry on. Take Fourier transform and multiply the spectrums. What is the answer? Very good. 0 is the answer. Because what is the Fourier transform? First one. Sin pi t by pi t rectangle from minus pi to pi. That is modulated by 3 pi units, sir. Another rectangle from 2 pi to 4 pi. Same rectangle right shifted by 3 pi units. The resultant product is 0. So what is the advantage of converting convolution to multiplication, sir? With less number of steps only, we are in a position to find out the output with less number of steps. Okay, the next property which we are discussing is called as frequency convolution. If you want to convolve in frequency, time domain it is multiplication, sir. If you want to convolve in frequency, time domain it is multiplication. This property has two applications, sir. This property can be also used as a modulator. Like frequency shifting property, we named as modulator. This property can be also used as modulator. Its second application is to get samples in frequency domain. Also, we need this property. We are proving sampling theorem because of this property. We are proving sampling theorem because of this property. Listen here. Till now, the theoretical statements we have made on properties. Shift in one domain corresponds to multiplication by exponential term in other domain. Shift in one domain corresponds to multiplication by exponential term in other domain. The second statement, differentiation with respect to one variable is multiplied by other variable. Differentiation with respect to one variable is multiplied by other variable. This is the last one, sir. Convolution in one domain is multiplication in other domain. Convolution in one domain is multiplication in other domain. Everyone see the screen, sir, once. Suppose I want Fourier transform of xt cos omega naught t, sir. If I want Fourier transform of xt cos, before the break, we used a word, any signal multiplied by cos, sine or exponential means frequency shifting property. That is one style. Another style, you feel xt like one signal, cos like another signal. X of t one signal, cos another signal. Blindly we can apply this property or not. 1 over 2 pi xt means x omega convolved. Cos Fourier transform is what, sir? Pi into del of omega minus omega naught plus del of omega plus omega naught. Extra pi cancellation. Any term convolved by impulse means it is shifted by that much amount. Any term convolved by impulse means x omega convolved del of omega minus omega naught means shifted or not. Try to feel xt as one signal, cos as another signal. Multiplication in time domain is convolution in frequency domain. By that way also we got the answer. Please think of this model, everyone. Suppose I want Fourier transform of this function. It is like product of two SAP functions in time domain, sir. So get the spectrum. Tell me what is the spectrum graph? Tell me what is the spectrum graph? It is product of two SAP functions. Our style sin 80 by pi t. Our style is sin 80 by pi t. Come on, come on. Today, AC is also celebrating its birthday, 26 years. On November 14th, AC is established, sir. 26 years birthday. So do the required adjustment. Get the result. Correct, Dwarakanath. So do the required adjustment. It's a very easy question. Sin t by pi t, one term. Sin t by 2 by t, another term. But still we need pi, sir, extra. Still we need pi. So they are neatly looking like x1t multiplied by x2t. Pi into 1 by 2 pi. Fourier transform, first one is rectangle from -1 to 1 convolved with another rectangle from -half to half. What is convolution of unequal length rectangles? We know, sir. What is convolution of unequal length rectangles? We know. Trapezium. Add the lower and upper limits. Pi adjustment we have done 1 by 2 pi is because of the property. Very good, Venkatramana. Ravi. Dwarakanath. Yeah, Dirkar. Maybe it's true. In 2012, at the time, Institute is not having that many branches, sir. We got 34 batches, 2012. 34 batches, certain batches 200 strength, certain batches 300 strength, like that. Only for EC. Nowadays, every gully fellow is teaching the subject. The fellows who have learned from me, they are teaching in some other institutes. Mohammed, very good. You are a different person. You will always come with a different emotion. Very good, Mohammed. Okay. Let us see integration property in Fourier. Like differentiation is multiplied by j omega. Don't feel integration means simply divided by j omega, sir. Don't feel it. There we lost the DC, but integration is retaining the DC. So answer is x omega by j omega plus pi x0 del omega. There we said multiply by j omega. Don't feel here, simply divided by j omega. There we lost the DC, here we are retaining the DC. This extra term reflects any non-zero average value that is present because of integration. This extra term reflects any non-zero average value that is present because of integration. So there we observed spectrum at 0 may be lost, but here it is retaining it. One example to say, suppose we have chosen impulse. Suno first. What is the Fourier transform of impulse? We know 1. So spectrum at 0 is 1. Substitute the data here. Integral minus infinity to t del tau d tau x omega by j omega plus pi into spectrum at 0 into spectrum at 0 is 1 into del omega. Every one of integration of impulse is step function for which it is correct answer 1 by j omega plus pi del omega correct. Under time differentiation, what answer we got, sir? Only 1 by j omega. We lost impulse there, but integration is retaining impulse. And one more point you have to check. If I assume step function as yt, this is y omega. What is the graph of y omega? As omega increases, 1 by omega decreases. Anyway, impulse is represented by area. What is the graph of 1 by omega, sir? As omega is increasing, 1 by omega decreasing. Where more amplification is done? For low frequencies, more amplification is done. So integrator is acting like a low pass filter. Integrator is acting like a low pass filter. Why? When you look at the spectrum, for low frequencies, more amplification is done compared to higher frequencies. So in general, integrator acts like low pass, differentiator acts like high pass. How it is true? From the shape of the spectrum also, we can say it. From the shape of the spectrum. So time differentiation, we lost DC, but integration is retaining the DC component. Before applying integration property, check whether spectrum at 0 is possible or not. If it is defined, add that extra term pi x0 del omega. Add that extra term, sir, pi x0 del omega. Integration amplifies the low frequency components. One funny question was asked in one of the gate paper. I am giving it, try to answer it, sir. Very funny question. G of omega is given as omega into e power minus 2 omega square. Y of t is integration of g tau d tau. What is the value of integral yt dt? Area under the signal means take spectrum at 0. That is a logic. Think of g omega is given, sir. Y of t is integration of that signal. Means first we have to calculate y omega. Area under the signal means take spectrum at 0. Area under the signal means take spectrum at 0. Very simple question. Respond the answer. First everyone calculate y omega, then replace omega 0. You know the answer. What happened? What is the result? Chandrika correct, Ravi correct. Very simple question, sir. If you take Fourier transform here, it is g omega by j omega plus pi into g0 del omega. What is the answer for g0, sir? Omega plus 0 means 0. So this is gone. So y omega becomes these two cancellation. So area under the signal means spectrum at 0. What happens if we replace omega 0 here? E power 0 is 1, 1 by j. E power 0 is 1, 1 by j. So before using integration property, what is the extra care we should take, sir? Whether spectrum at 0 is defined or not. In this case, it is 0. If it is defined, add pi x 0 del omega additional term. Add that. Take another short break of 15 minutes. We'll discuss the last property, Parseval's relation of Fourier transform. Take another short break for 15 minutes, sir. Okay, let us continue. The next property which we are discussing is Rayleigh's energy theorem. For energy signals, the word Rayleigh's is used, sir. Power signals, we can call that as Parseval's power theorem. Rayleigh's energy theorem, or its other name, Parseval's power theorem. If xt transform pair with x omega, then integral mod xt whole square dt equals to 1 over 2 pi integral mod x omega whole square d omega. In terms of f symbol, it is simply integral mod xf square df, because d omega by 2 pi is df. Magnitude whole square is called as the spectral density. Magnitude whole square is called as spectral density. As we are doing integration here, sir, area under spectral density represents energy or power in the signal. As we are doing integration here, area under spectral density represents energy or power in the signal. Depending on the nature of original signal, it may be called as energy spectral density or power spectral density. If xt is an energy signal, sir, the word ESD is used. If xt is power signal, then the word PSD is used, power spectral density. Of course, if the considered signal is power signal, compulsory what we require? Time average, 1 by 2t both sides. See, we are practically comparing the spectral density versus frequency, not spectrums. When you are listening to music, you are going to observe so many visualization tools, like Spotify, Winamp. There are so many musical tools. If you observe that visualization tool, it will show the variation of the song versus frequency, that is spectral density versus frequency. Certain times peak value, certain times valley, like that. So on the y-axis, we are observing the spectral density versus frequency. That tool is called as spectrogram. It is a visualization tool that will tell how much of energy is concentrated for certain frequency region. How much of energy is concentrated for certain region. So area under spectral density corresponds to what for us? Area under spectral density corresponds to energy or power in the signal. Area under spectral density corresponds to energy or power in the signal. Just go through the property, everyone, first. Be careful with two words, sir. X omega means just a spectrum. Magnitude whole square is called as spectral density. How much of input information is exactly retained at the output side, that is measured by using this. How much of input information is exactly retained at the output side is measured by using spectral density word. So let us solve few examples on this concept, Parseval's theorem. If I use the word Rayleigh's, don't confuse. Mathematical expression is same. Power signal means time average limit t tends to infinity 1 by 2t. Suppose one minute, sir. Suppose the question asked is get the energy in sin A t by pi t. We cannot solve this question easily from time domain. So take its Fourier transform. What is the Fourier transform of sin A t by pi t, sir? A rectangle that covers from minus A to A. From the last slide, what is the range of spectrum that is varied? Minus A to plus A. It is a band limited spectrum. So energy in the function is 1 over 2 pi integral minus A to A 1 whole square d omega. Answer becomes A by pi. Answer becomes A by pi. It is not easy for us to answer this question from time domain. So take its spectrum, get the results. Take its spectrum and get the result. Of course, if A value is pi, we know it is sync pulse or not, sir. If A value is pi, it is sync pulse, sin pi t by pi t. So now you tell me what is integral sync square t dt answer? Integral signal whole square is energy, sir. If you substitute A place pi, it becomes sync pulse. What is the energy in the sync pulse? That answer also 1, pi by pi. Energy in the sync pulse is 1. How it is 1? If you substitute A plus pi, rectangle covers from minus pi to pi. Pi by pi becomes 1 or not? Normal area under sync function 1. Area under sync whole square also 1. This has 3 properties, sir. It is integrable. Normal integration finite. Also square integrable. Means energy is also finite. But not absolutely integrable. Normal area finite. Square integration means energy also finite, sir. But absolute area is not finite. Where we require this absolute area concept? LTI system stability is absolute area. LTI system stability is absolute area. Its normal area finite. Energy also finite. But absolute area becomes infinity. But as usual, in the exam, they will not ask the question, find the energy in sin A t by pi t directly, sir. They will not ask like that. They may frame the question something like this. What is the energy in 4 sinc of t by 5? Every fellow should respond now. It must be appear like sin A t by pi t. Do the conversion and get the answer. It must appear like sin A t by pi t. Use Parseval's theorem and get the answer. Everyone, make a try. How much, sir? Very good, Srikant. Convert that to sin 80 by pi t form first. Sin 80 by pi t form, you convert. Chandrika, Kiran Kumar, correct. It is like 4 sin pi t by 5 by pi t by 5. So when you take its Fourier transform, that rectangle covers from minus pi by 5 to pi by 5 with amplitude 20, sir. 4 5s are 20, that is extra. So energy becomes how much? 1 over 2 pi minus pi by 5 to pi by 5, 20 whole square d omega. Answer becomes 80 joules. Correct or not? Spectrum amplitude whole square. Think of this model. Find the energy in the spectrum shown in figure. Directly spectrum is given. We want energy, sir. Again, Parseval's theorem. Actual integration is minus 1 to 1, sir. But because it is even symmetric, 2 times 0 to 1 you can take. Because it is even symmetric, 2 times 0 to 1. Carry on. Minus 1 to 1 mod x omega whole square d omega. That is 2 times 0 to 1. Because of even nature, sorry, 0 to 0.5 range, amplitude given as root pi by 2, sir. 0.5 to 1 range. First time 1 by 8, next time 1 by 2. Of course, that is a simplified answer, right? One by 8 plus 1 by 2. Okay. Wait. Think of the left side question, sir. Find the value of the given integral. 8 by omega square plus 4 whole square d omega. The handwritten notes of me review notes is uploaded in the site. What to remember conclusion points, whether it is uploaded or not, sir? Have anyone cross-checked? Okay. After completion of every chapter, just refer it. Some 15-16 pages I have written. What to remember in each topic that is available there. This problem we cannot solve directly in frequency domain, but the denominator indicates it corresponds to two-sided exponential. E power minus a mod t means 2a by a square plus omega square. Spectrum whole square is there means it corresponds to two-sided exponential. Use the hint, apply the property, tell the results, sir. Use that hint. So this is actually adjusted as 2a by omega square plus a square, total term whole square d omega. So numerator we have 16, but only 8 multiplier is given means we adjusted 1 by 2. We adjusted 1 by 2. When you apply theorem, what will happen, sir? 1 by 2 into 2 pi extra. Why I am multiplying 2 pi, sir? Because integral spectrum whole square means 2 pi into energy in the signal. 2 pi into energy in the signal. Integral of mod e power minus 2 mod t whole square. So two-sided exponential is even function. So this can be written as 2 times 0 to infinity e power minus 4t dt, which is pi by 2. 2 pi by 4 is the answer, pi by 2. Actually, what is the difference between this SAF function example and this example, sir? In the case of SAF function example, we are unable to get the energy answer from time domain, so we have taken frequency domain. In the SAF function example, we are unable to get the answer from time domain, we have taken in frequency domain. But this example, we are unable to get the answer in frequency domain, so we converted back to time domain. From the two examples, it is indicating that if you fail in one domain, other domain, definitely you will know the answer. Wherever integral signal whole square or spectrum whole square is there, what is the immediate thought we need, sir? Integral signal whole square or spectrum whole square means what is the immediate thought we need? Application of Parseval's theorem. That is the immediate thought we need. Okay? Please think of this. Mod xf is given. We want energy. It is also symmetrical function. If you find that ramp expression, it will appear like this, sir. So energy in mod xf is actually minus 10 power 4 to 10 power 4 mod xf whole square df, which is 2 times 0 to 10 power 4. Square of this means 10 power minus 12 into whole square df. That we have to simplify to get the answer. Finding the ramp expression, then after that integration. But 50% of the fellows will fail in the ramp expression. Recollect everyone, what is the direct logic we know, sir? Triangular pulse of width t, amplitude a. What is the energy answer? A square t by 3 logic. A square is 10 power minus 6 whole square. Width of the spectrum 2 into 10 power 4 by 3. A square is 10 power minus 6 whole square. Width of the spectrum 2 into 10 power 4 by 3. Blindly applied. A square t by 3 logic. Instead of finding the ramp expression and making it further lengthy. Okay. Think of this model. Input signal is given as a decaying exponential that is passed through ideal low pass with frequency response characteristics. Find omega c such that energy in the output is half that of input energy. What information given is input decaying that we want to pass through ideal low pass. We are getting some output, but the question is find energy in the out, find cutoff such that energy in the output is 1 by 2 times input energy. After taking this data, you require the idea which properties to be applied, sir, for simplification. Which properties to be applied? Input and system are known, get the output means convolution. Because it is related in terms of energy, Parseval's theorem. Input and system are known, get the output means convolution. Because it is related in terms of energy, Parseval's theorem. First step here, calculate the energy in the input such that we will know energy in the output. How to obtain energy in the input, sir? 0 to infinity e power minus 2t whole square dt, that is 1 by 4. Automatically energy in the output is how much? Half times input energy means 1 by 8. That is the first step. Second step, calculate output spectrum. Calculate output spectrum. Y omega is x omega into h omega. That is 1 by 2 plus j omega into 1. Input for a transform 1 by 2 plus j omega, filter response 1. As filter is band limited, output spectrum band limited. As filter is band limited, output spectrum is band limited. We know output energy and we know output spectrum. We know output energy, we know output spectrum. Apply Parshall's theorem for output, sir. That is the last step. I'll come back there, wait. When you apply the theorem for output, energy in the output is 1 over 2 pi integral mod y omega square d omega. Left side quantity number 1 by 8. Energy in the output 1 by 1 over 2 pi. Right side integration varies from minus omega c to omega c. 1 by 2 plus j omega whole square d omega. This integral we have to solve. As magnitude whole square is even symmetric, it becomes 2 times 0 to omega c, sir. So this is looking like which standard integral? Integral 1 by x square plus a square dx means 1 by a tan inverse x by a. So when you apply that, 2 into 1 by 2 tan inverse omega by 2 over the limit 0 to omega c. Tan pi by 4 is 1. Omega c becomes 2 radian per second. You can do all this mathematics only if you got the idea which properties to be used. Input and system are known, get the output means convolution because it is related in terms of energy. Parshall's theorem of output. Apply Parshall's theorem for output. Just go through the steps, sir. Go through the steps. First we calculated input energy such that we got output energy as 1 by 8. Then we calculated output spectrum, sir. As filter is band limited, output spectrum also band limited. Finally, we applied theorem for output. Okay. Let us discuss the next model. What is the absolute bandwidth of sinc alpha t? H of t is given as sinc function. What is the absolute bandwidth? What is the expansion of this one, sir? Sin pi alpha t by pi alpha t. So what is the spectrum? Sin a t by pi t means we are taking a rectangular spectrum for which range? Minus pi alpha to pi alpha. So what is the absolute bandwidth? Bandwidth definition is valid only for positive range. Bandwidth definition is valid only for positive range. What is the 3 dB bandwidth of a decaying exponential? E power minus pi t ut. What is the 3 dB bandwidth? 3 dB bandwidth means at that frequency magnitude becomes 1 by root 2 of the value at origin, sir. At that frequency magnitude becomes 1 by root 2 of the value at origin. So think of and respond. What is the 3 dB bandwidth of this system? Correct, Ravi? What is the Fourier transform of this term? 1 by 5 plus j omega. So magnitude whole square is mod h0 whole square by 2. Okay. Mod h0 whole square by. So what is magnitude of this term? 1 by root of 25 plus omega square. So mod h0 becomes 1 by 5. That is 1 by 25 plus omega c square is 1 by 5 whole square by 2. From which 25 plus omega square is 50. Omega c becomes 5 radian per second. But there is no need to solve this problem because the decaying exponentially is the impulse response of standard RC filter. The impulse response is what, sir? 1 by RC e power minus t by RC u of t Time constant is RC, omega C is 1 by tau. Every one of you know it. It is the impulse response of RC filters. 1 by RC e power minus t by RC. Tau equals to RC, omega C is 1 by tau. What is that omega C number neatly visible? 5. That itself is the answer. No need to solve it. Because it is the impulse response of RC filter. There is no need to solve the problem, sir. Suppose I have given e power minus 3t ut and asked for what is omega c. Answer is 3 directly. If I have given e power minus 3t ut and asked for what is omega c, directly number 3. No need to solve. Okay. Suppose a question is asked like this, sir. What is the value of this integral area under product of two signals? Area under product of same signals is Parseval's. Mod xt square meaning is xt into x star t. Area under product of two different signals is Plancherol's. xt into y star t. Instead of xt into xt, we are taking xt into y star t. 1 over 2 pi x omega into y star omega d omega. If one of the signal is complex, then we need conjugation, sir. That is called as Plancherol's theorem. Parseval's theorem meaning is what? xt into x star t. Left side. Instead of xt into x star t, now it is xt into y star t. Right side, mod x omega square meaning is what, sir? X omega into x star omega. But now we can write that as x omega into y star omega. Of course, if you want, in terms of f symbol, without 1 by 2 pi, because d omega by 2 pi is df. D omega by 2 pi is df. Latest gate paper, you got Plancherol's theorem question from DTFT chapter, discrete time Fourier transform. You should remember that area under product of same signals is Parseval's. Two different signals is Plancherol's. In our example, they are real signals only, sir. In the question which I have given, this is real, this is also real. So just multiply the spectrums and check what is the integral answer. Anyone? Respond. Just take Fourier transform of both functions. 12 sin 4t spectrum you draw. Cos 2 pi t spectrum you draw. Multiply and simplify. No, Kiran Kumar. That is wrong. Correct, Ravi? Twelve sink 4t can be expanded as 12 sin 4 pi t by 4 pi t. It means it is a rectangle for what interval, sir? Minus 4 pi to 4 pi with amplitude 3. Other one cos 2 pi t. That is 2 impulse at plus or minus 2 pi with weight as pi. Just take product of them. Again, product property of impulse, sir. When you multiply them, they are product property of impulse. Any term multiplied by impulse means impulse will be retained as it is. So 1 over 2 pi integral of here 3 pi into del of omega minus 2 pi one term, 3 pi into del of omega plus 2 pi another term. Any term multiplied by impulse means we are retaining the impulse at that frequency as it is. 3 into pi, here 3, sir. So answer is 3. Area under product of same signals Parseval's, 2 different signals is Plancherol. This year for us, Parseval's theorem of Fourier series 2 marks question. Plancherol's theorem of DTFT is 2 marks question. Both are fill in the blanks. The exams are. Both questions fill in the blanks. Okay. In a similar way, suppose I asked, what is the value of sinc cube f df? Sinc cube f. Sinc cube f can be adjusted as what? Sinc f into sinc square f. So this is like xf. This is like yf. From the last slide, what is integral xf yf, sir, in time domain? Xt into yt. So apply Plancherol's. When you apply Plancherol's theorem, what you can feel? Sinc f is Fourier transform of rectangle. Sinc square is Fourier transform of triangle. First function sinc f is rect t. Sinc square f is tri t. So what is the product of the functions we are taking, sir? Rect t means minus half to half. Tri t means minus 1 to. After multiplying both functions, resultant will look like what? After doing multiplication, resultant will look like this shape or not? Like a home shape. Just find out the individual area. Bacha, what is there? Rectangular part area and triangular part area. That will make 3 by 4. Rectangular part area half, sir. Triangle half base height. Half base 3 by 4. So when we were child, we used to draw a home shape like this. Even at this age also, what we are sketching? Same home shape only. But build up is Plancherol's theorem. Again, why I discussed two models here? Previous example, we are not in a position to say answer from time domain. So we have taken spectrum. This example, we are not in a position to say answer in frequency domain. So we converted to time domain, sir. So on today's discussion, I am giving some problems for you, practice or everyone on today's discussion. Okay. I am moving to next slide. What is the value of same question slide modification? Singapore 4FDF. That is one question. This is some signal x of t given, sir. That fellow want what is the value of by the time I am giving homework questions, some fellows are getting loose motion. Huh? Funny fellows. Everything in life, hurry, instant. This is another model. Xt is given. He wants the value of integral mod x omega whole square d omega, sir. Means Parseval's theorem. This answer 2 by 3. This is 56 pi by 3. Solve, then you'll know. Okay. Area under hundred sink of t minus 8 by 30. Area under the signal means where we are taking spectrums are at origin. Last question. Find the output of a filter with impulse response given as sync pulse to different inputs, sir. One input is given as 1. Another input is given as cos 2 pi t. For the same system, if you apply 2 inputs, what are the outputs? All red color marked one are answers. Make a try. You only tell me on which signal we concentrated more today, sir. We discussed some 10 to 12 properties. Which signal I concentrated more? Rectangle in one domain becomes other domain what? SAP function or sync function. On that only we discussed maximum number of questions or not. Maximum number. Rectangle in one domain becomes SAP function or sync function in other domain. So try to practice them. Okay. Tomorrow's session, don't forget, 4:30 it will start. 4:30 to 6:30 I'm taking. Coming Monday also session will be like that only. Only Monday. There is a small change. Okay, that's all for today. Enjoy the Sunday afternoon session. Thank you. Okay, bye everyone.